Hello guys, this is Prime Concept. We want to look at a very important topic in mathematics that is known as complex number. Ab initio or before now, we have started learning numbers in our primary schools. And when we first learned numbers in primary school, we were restricted to a certain kind of number known as the natural number. These are just what we know as families of number. So one of the families we started counting with is known as the natural number, which is denoted by this. A set of natural numbers is denoted by this. And what are the natural numbers? The natural numbers are counting numbers. They are positive integers. So the natural numbers can be 1, 2, 3, 4, 5, 6, and so on. These are natural numbers, and these are numbers we learned how to count with. And in our primary school days, when we do something like 4 minus 3, would quickly do this and say that the answer is 1, right? Yes, because these are natural numbers. Now, we went on in primary school to learn that when we now do something like 3 minus 4, now because 3 is less than 4, in primary school, we say that this cannot go. This is how we learned in our primary school, in our basic level. We say it cannot go. But then when we advanced up to our secondary level, we now saw that when you say 3 minus 4, you discover the answer will be minus 1. This was now allowed. So it means there was an extension to the natural number. So we advanced to what we know as integers, right? And our integers would include both positive and negative whole numbers. So we began to learn advanced concepts. Now, later on, we began to learn generally both decimals to include both decimals and so on. Then this extension is actually that includes both decimals is actually what we know as what as the real number. Now, at this point, we want to look at another kind of number which is known as complex number. And for the sake of learning, you should understand that the complex number is the largest number in the number system. It is the largest number. What it means when we say the largest number, it means that every other kind of number we can think of, the natural number, the irrational number, the rational numbers, the real numbers, the integers, all these type of numbers are under the complex number. So complex number is the biggest among the families of number. That is the first thing I want to establish, which means that every number you can think of is actually a complex number. But let's begin with the knowledge of complex numbers. So what are complex numbers? Complex numbers, these are numbers. These are numbers that are composed of two parts. They are numbers composed of two parts, which is denoted as z equals x plus iy. So a complex number is a number that is composed of two parts. So you can clearly see that this is one part of this number and this is another part of this number. Where I want to point out that x and y, they are all members of what we know as the real numbers. That is to say, x is a real number, y is also a real number. X can be any number you can think of. X can be 2, x can be minus 3, x can be 1, x can be 0.5, x can even be 0. Y can be any of these numbers. So these are both members of the real number. In this particular notation, this is the notation for complex number. In this particular notation, x in that case is known as the real part. X is the real part. Is the real part of the complex number. So if they give you something like this, say which is the real part, The part that does not contain I is the real part, right? Then, which we often write like this for short, RE, the real part of Z. So X is the real part of the complex number Z. Remember, Z denotes the complex number, right? Yes. Then also, Y is actually known as the imaginary part, so which we denote as IM of Z. So Y is the imaginary part of this. Then I is a special quantity. So I is known as the imaginary factor. Imaginary factor, right? Yes, and I was agreed upon to be called the square root of -1. So it was actually trying to solve some kind of quadratic equations that led to this concept. And when it became a problem, the earlier scientists or mathematicians decided to create an extension to the real number so that equations such as the quadratic equation can be easily solved in what we know as a complex plane. So I represents the square root of -1. So let me give you a very quick example. But before that example, let me show you that since we have agreed that X can be called the real part of Z, and I've said Y can be called the IN, which means imaginary part of Z. It means another way I can denote this complex number is to say Z is equal to the real part of Z, which stands for X now, plus I times the imaginary part of what? Z. Means I can still denote this same complex number in this form. So this Z is just used to represent a particular complex number. It's not a set, just one complex number. So an example, we can say that Z, which represents a particular complex number, would be equal to, let's say, 2 minus 4i. Remember, if I put this I in front of 4 or at the back of 4, it means exactly the same thing. So if I give a complex number this way, and I ask you, what is the real part of this complex number? What would you tell me? You are very correct. You would quickly tell me that the real part is equal to what? Is equal to 2. That is very simple. I ask you what is the imaginary part of Z, you would quickly tell me that the imaginary part of this complex number Z is equal to what? Is equal to negative, so don't forget, is equal to -4. Please don't say -4i. You would say it is equal to what? -4. That is the imaginary part of the complex number. And you would have quickly noticed that for every complex number, the complex number is made up of real numbers. Of course, obviously 2 and -4 are real numbers. That is what we've earlier stated here, right? So that when you put them together in this notation, you will now say this is the real part. I say this is the what? Imaginary part of this complex number. Then I want to also mention to you that we can have a complex number like this. We can have Z to be equal to, let's say, 4. And what will you quickly notice? You'll notice that in this particular case, our complex number does not have the imaginary component. It has only the real component. So in this case, we would say that our complex number is purely what? Real. So this is a purely real complex number. The complex number is purely real. That is what it means when it has only a real part. And obviously you can see that 4 is a real number. So it quickly tells you that all real numbers are complex numbers, but not all complex numbers are what? Real numbers. So let me write it as a point for you to note. All real numbers are complex numbers, but not all complex numbers are real. So please take note of this, because this z equals 4 is a real number, and it's also a what? Complex number. So we would say that this complex number is made of only a real part, and the real part is what? 4. So if I ask you what is the imaginary component of this complex number, what will you tell me? You would say it is what? 0, right? Because it is not present there. Now also, you can have a complex number this way. You can have z equals, let's say, 5i. You can have a complex number this way. So if you have a complex number this way, you quickly notice that it is made of only an imaginary part. So you quickly say that this complex number is purely what? Imaginary. It is purely imaginary. It is purely imaginary. So meaning that it is made of only an imaginary part. So if I ask you, what is the imaginary part of this complex number? What is the imaginary part of z? You quickly tell me it is what? 5. But if I ask you, what is the real part of z? What would you tell me? You will tell me that it is what? 0, because it is not present there. So this complex number is said to be what? Purely imaginary. So I believe this is very clear to you. Now, I also want to point out to you that just like we have a set of real numbers, when we say a set of real numbers, is a set that contains all real numbers. And what are real numbers? Real numbers are numbers from negative infinity to positive infinity. So we have a set of real numbers, and a set of real numbers is denoted by this symbol, right? Yes, so whenever you see this, it means a set of real numbers, which is not what I'm dealing with for now. But then I want to also make you know that a set of complex numbers, a set that contains all the numbers you can think of, which are actually members of the complex set or plane, it's denoted as this. So when you see something like this, this means a set of complex number. A set of what? Complex number. So what it means is that if I do something for you like this, if I say, let's say x is a member of this, if I do something for you like this, how would you interpret it using the set notations I've given? You would simply say that x is an element, or you say x is a member of the complex number. That's what it means, right? Yes, and I'm going to take some problems as we move on. So quickly, let's still do some basic solving, then we can call it an end for the first introductory part of complex number. Now, we want to look at how to write numbers in terms of I. So write the following in terms of I, the imaginary factor. So we want to write some complex number in terms of I. So number 1, we want to write the square root of, let's say, minus 2. We want to write this in terms of I. Number 2, we want to write the square root of minus 4. We want to write this in terms of I. Number 3, we want to write minus times the square root of, let's say, negative 9. We want to write these 3 things in terms of I. Remember what we have earlier agreed. Now, just as a reminder, what actually led to the concept of complex number is when the earlier scientists were solving mass equation, they got to a dead end. And what was that dead end? They arrived at a point where they got negative inside a square root. So when they got to that point, not just square, but then for this basic level, square root, when they got to that point, of course, you can quickly test this with your calculator at home, your simple calculator. If you punch the square root of minus 2, it will tell you mass error. So they decided that it is actually time to extend the real number to another plane, which we know as a complex plane. So what gave rise to the concept of complex number is the advent of negative signs inside a square root. That's what gave rise to complex number. So let's see how we can reduce this to complex number in terms of what? I. So I'll call the first one z equals the square root of minus 2. This is what we have there. Now, anytime you have a problem like this, what I want you to do is to remember your sword in mathematics. Remember your sword. So you should know that minus 2 is exactly the same thing as saying 2 times minus 1. They are the same. So anytime you're given any problem like this, separate them by saying the number times negative 1. Whatever number it is, that number times negative 1. So I have that z is going to be, I can now split this by what I know from sword. I can split this by saying square root of 2 times square root of negative 1. I can split in this way. And therefore, I would have that z is square root of 2, which is a sword. I can no longer evaluate. Now, but if you recall, earlier in this class, we said that the square root of negative 1 should be called what? I. So it means in place of square root of negative 1, I'll just write what? I'll write I. So it means I've written this complex number, square root of minus 2, I've written it in terms of I. So this is the advent of complex number. Now, if I should ask you, what is the real part of this complex number? What will you tell me? Quickly, you will tell me that the real part of this complex number is what? 0. What is the imaginary part of this complex number? You quickly tell me the square root of what? 2. Now, let me solve this. Number 2, let's see. Number 2, we have z is equal to the square root of negative 4, which I can write as 4 times negative 1. Then I would say that z is equal to, I can split this now. I would say square root of 4 times square root of what? Negative 1. So I can split it. And quickly you would see from there, you would quickly see from this that z should now be, what is the square root of 4? Square root of 4 is 2. Then what is square root of negative 1? The square root of negative 1 is agreed to be called what? I. So it means that my z is equal to what? 2i. So I've written this in terms of I also. Now I want to solve number 3, and now that will bring us to the end of the video. Now, notice there's a negative outside. So let's do it this way. Let's say our z is equal to negative of root negative 9. This is what we have. So leave this negative, keep maintaining that it does not affect what we're doing. So z is negative into square root of 9 times negative 1. Then my z is negative into square root of 9 times square root of negative 1. So I can then say my z is negative, still outside. And what is the square root of 9? The square root of 9 is 3. So I have negative 3. Now, what is square root of minus 1? It is known as what? I. So it means that my z is equal to negative 3i. So this is what you should know basically for complex number. So I believe what we have done so far is really very clear to you. I would like you to drop any question you have on complex number. I believe that complex number is really a new idea to a lot of university first year students. This is one topic that most people did not get to do in secondary school. So it means it will require a gradual learning for you to really understand it. I would encourage you to subscribe to this channel. I'll be dropping a lot of videos on complex number that will make it easy for you to navigate through complex number. So if you are watching me and you are yet to subscribe, just quickly hit the subscribe button, share this video with your friends. If you have any challenge, any question, drop it on the comment section. I will attend to your question. I'll see you in my next video. This is Prime Concept. Thank you.